Good evening everyone. Myself G. Pranigrai. I am going to tell you how to draw the ray diagram. What is a ray diagram? A ray diagram helps us to construct the image, to find the nature of the image, whether it is inverted or erect, whether it is real or virtual, whether it is your magnified or diminished. Most of the students, whenever they are drawing the diagram, like let us take an example here. Suppose I want to draw for a convex lens. Right? So if I want to draw the ray diagram for convex lens, so what I have to draw? Now first I have to draw a vertical line. This is denoted by LS, which we call as a convex lens. Then I have to draw principal axis. This is a principal axis. And this point is called the optic center O. Then roughly what we do, we mark certain thing. So like this, what the O to F. So one point we mark as a F1, focus point. So this length again we take a double, approximately as a C1. Right? And same on the left side, your this length we take as a F2, and double length we took as a C2. And whenever we are drawing the ray diagram, so what is the problem here? Suppose I kept the object at the C point. So whenever you are drawing, some bending occurs. Sometimes you may use the scale, but sometimes bending occurs. And because these lengths we are not taking properly, so because of which as we kept the object between beyond C, so this is our object. So sometimes what happened, the image, our ray diagram image could not be formed between between F1 and C1. So let me show you example here. Suppose I have taken one parallel beam applied. Here these lines are not exactly parallel. Okay. So it is passing through the focus. So this is a refracted ray. Second one, through the optic center. So this is through optic center. So see here, what is the problem here? When I am drawing the straight line, so the line is going to meet beyond center of curvature. So here the image is going to form here. So which is wrong diagram. So this diagram is wrong. That's why we need to practice it on a graph sheet. We need to practice it on a graph sheet so that you will get exact picture, exact diagram. So that I am going to help you today. So today our topic is how to draw ray diagram for convex lens and concave lens. So for convex lens we are going to draw 6 diagram, and for concave lens we are going to draw 2 diagrams. You can observe in my hand, there are 2 graph sheets are there. So on this 2 graph sheet, we can draw 8 number of diagrams. How? The first you fold this graph sheet into 2 equal parts. So this is I am folding it into 2 equal parts. So this is one part. Right, so I fold it like this. Okay, then you fold this paper into another 2 pieces. So again you fold it into half. Right, then you just open it. So when you open, you will find there are 4 blocks are there. 1, 2, 3, 4. And the back side another is there, so that is another 4. So total 8 number of blocks are there. So in this 8 diagrams are sufficient. So in the first you will go for 4 from one lens and 2 from another lens on this side, and rest 2 for another lens. So total 8 we can draw. 1, 2, 3, 4, 5, 6, 7, 8. So first you have to take a graph sheet and you have to fold into 4 parts. So that we'll get 8 blocks. What's it? Okay, after folding into 4 equal parts, so you have to check where is the midline. So you count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So 13 means half is how much? 6 and half means 7. So 1, 2, 3, 4, 5, 6, 7. So this is the midline. So you have to draw what the vertical line here. So this is our vertical line as a lens. So you have to draw exactly. This is the lens, right? Okay. So now here what you have to check which should be our principal axis. So you have to count here 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 5. 1, 2, 3, 4 and 5. So this is our principal axis. So when you are drawing the principal axis, at a time you draw, right, so that it will be easier for all, because same line you will get in all diagram, right? Oh, this is our principal axis. Okay, so let us mark from here. And don't elongate. Here a block is there, so you keep up to this extent. And here you can start from here and up to this. So this is our principal axis. Okay. So now let us check whether it is middle or not. I think it is not middle exactly. So that's why it is not coming properly. So let me check. So how much counting is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 means 6. 12 means 6. 1, 2, 3, 4, 5 and 6. So you keep this one as a the lens and you draw in everywhere. So that is 6. Okay, and don't draw, just you draw 3 centimeter up and 3 centimeter down. So 3 centimeter down. So 3 centimeter up, 3 centimeter down. So the same you can draw here. Okay, afterwards we will see. So here also you should start with 6, right? So you have to go for, you have to count 1, 2, 3, 4, 5, or right side onwards you count. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 means 5. So from here 1, 2, 3, 4 and 5, 5 and half means 6 you keep. So here 6, I kept on 6. So same 3 centimeter up and 3 centimeter down. Right, here also you mark the same. Okay. So now here it is our paper is ready, right? So coming to here. So here you count the number of division. 1, 2, 3, 4, 5, 6, 7. So count it once more. 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 means 4 and a half, means 5. So from here 1, 2, 3, 4 and 5. So this line. So this line at a time you can draw a straight line so that all the 4 will be ready. So right, and for second block also same. Right, so our 4 diagrams are ready. So now you check whether 3 centimeter up is there or not. 1, check it here whether 3 centimeter up is there or not. 1, 2, 3. 1, 2. Here it is not touching, so let us go for 3. Okay. Then in the fourth one, right, here also the same thing. So 1, 2, 3, 1, 2, 3. So 1, 2, 3 down, right, and 1, 2, 3 up. So now after drawing these, so you have to mark. What you have to mark? The optic center, lens and everything. Right. So here mark this as L dash. This is optic center O. Same. All you have to mark in the same way. Right. L dash, optic center O. Here also the same thing. Right. So now what you have to do, as this is the principal axis, so you take 2 centimeter as the focal length and 2 plus 2, 4 centimeter as center of curvature. So you mark it as what a F1 and this is what a C1. Similarly, on the left side, 2 centimeter F1 and 2 centimeter is what a C1. So this is a F2 and this is C2. Right. Okay. The same thing you have to mark in all. So C2, F2, 2 centimeter, F1 and C1. Right. Here also the same thing. Okay, so this is you're going to get here C2, F2, then F1, C1, again the same. So C2, F2, next F1 and C1. Okay. Now our 4 diagrams are going to be ready. So first what you have to do, here what you write, this is for a convex lens. Okay, because arrow mark is either side, so it is a convex lens. So first case 1. That means object is kept at infinity. Object kept at infinity. Right. So object kept at infinity means we'll get a parallel beam of light. So you have to draw parallel beam of light. So how many parallel? Now above the principal axis 2 and below the principal axis 2. So here we get the parallel beam of light. So this is one parallel beam of light. Next this is the second one. Right. So two parallel beam of light. So put the arrow mark here. And 2 down. And 2 down. So this is one parallel beam of light. And this is the second parallel beam of light. So as you know very well, all the parallel beam of light, so you have to mark it as incident ray, IRs. Okay, all the parallel beam of light after passing through the convex lens, it passed through the focus. So it converges at focus. So from this point to focus you have to join. Like this. From this point join. Right. From this point join. And from this point join. So our diagram is ready. Now you put arrow mark here because these are refracted ray. So these are refracted ray. Okay. So here you have to mark the, you have to write here image. Where is where the image is formed. So on the left side you write about the image. Right. So here object, this is image. Point number 1. Where it is formed? The image is formed at focus. At focus. Right. Second. What is the nature? The nature is real, inverted, and highly diminished. Highly diminished means it is point size. Point size. So if the object is kept at infinity, we get what? Parallel beam of light, that is parallel to the principal axis, and after refraction they converge at focus. So the image is going to form at focus and it is real, inverted and highly diminished. So it will be become a point size. So first option over. Okay, first diagram over. Second option, object kept beyond C. Beyond C. Beyond C means 2f length. Beyond C means what? 2 times of focal length. Means at after radius of curvature. Okay. So here object. So here what you have to do? Just because your center of curvature is 4 centimeter. So you keep the object at 5 centimeter. Okay. So keep the object at what? 5 centimeter. And you keep only 2 centimeter height. Don't go more than. So 2 centimeter height we should keep because it is a graph sheet. So already it is perpendicular. So you mark as A and B. This is your object. Now you have to draw what as per our rule. So first you have to draw parallel beam of light. So this is the parallel beam of light from the tip. Right. So this is incident ray. So it will pass through the focus. It will pass through the focus. So this is the first refracted ray. Then you have to what you have to do? Now from the tip to the optic center you have to draw. you have to join. Because the light ray that passed through the optic center, it remain undeviated. So you have to draw straight line. Right? So this is our incident ray and this is our refracted ray. Now where the two rays are meeting, so this is the meeting point. So from this meeting point, you have to draw, put a perpendicular on the principal axis. Right? So this is our image. So this is put a perpendicular. And you mark this one as your B dash and this is A dash. This is our image. Now you observe where the image is forming. So it is forming between F and C. F and C. So you have to write here image, about image. What you have to write? The first point, it is formed between what? Between F and C. F means small f focal length and C, center of curvature, means 2f focal length. Right. F and C. Second point, you have to write second point. What is the nature? So you observe here, size is smaller here getting, because here 2 centimeter height, here we get what, 1.3 centimeter. So that means size is decreasing here. So it is a real image, real inverted, because the direction is down and it is opposite. So it is inverted and diminished. Okay, over. So this is the second diagram over. Now coming to the third one. So our third one is what? Third one is the object kept at C. So what is our topic? Object. So this is the third option. C. Object kept at center of curvature or 2f length. So that means at 4 centimeter you have to draw. So here don't take 2 centimeter. You have to take only 1 centimeter height. Only 1 centimeter height, then an accurate picture will come. So you have to take only 1 centimeter height as an object. So you keep the object height only 1 centimeter. More than 1 centimeter don't take. So you have to keep the object at the center of curvature. So at the C2 point. So this is our, so mark this as A and B. This is our object. So 1 centimeter. Then same as per our rule. First you have to draw what, a parallel beam of light from the tip. So this is the parallel beam of light and it will pass through the focus. So it will pass to the focus. Yes. So you can observe here it is C point only. Okay. Because it is a graph sheet, you can identify very well. So this is our incident ray. Right. This is our refracted ray. And second ray through optic center. Through what? Optic center, which will remain undeviated. Right. Exactly it is meeting at the C point. So here you have to draw, put a perpendicular on the principal axis. It is nothing but forming at the C point. So this is our B dash point. Okay. And this is our A dash point. And this is our image. So don't take more than one. If you take more than one, the ray diagram will not come. So exactly it will not form at C. So you have to take care here. In case of the if the object is kept at C point, You have to take only 1 centimeter height. Now let us write where the image is going to form. So let us write about image. So image, first point, it is formed at center of curvature only. That means 2f length only. Second point, what is the nature? You observe here, the two refracted rays are meeting, so it is a real image. It's a real image. So real. Next, downward direction, this is up. So opposite direction means inverted. And see here, what is the height you have taken? 1 centimeter. What is the height you got here? That is also 1 centimeter. Means same size. Right. So this is the third option over. Next, coming to the fourth option. So what is our fourth option? Fourth option means the object is kept, where the object is kept? Between F and C or C and F. So here, the fourth option, what you have to write? Right. So what you have to write? So you have to write object kept between F means here what the focal length F and C. That means 2F length. Means C and F. You can write also C and F. Right. So C and F means F is what? F is here 2 centimeter. C is 4 centimeter. So you put a perpendicular in between them. That means at 3 centimeter. And you draw only 1 centimeter height here. Okay. So at 3 centimeter, draw 1 centimeter height. And mark this one as A and B. This is your object. As per our rule, you have to draw parallel line from the tip. So this is a parallel beam of light. So it will pass through the focus. So from this point, focus point, you join and elongate. So this is our incident ray. This is our refracted ray. Okay. Second ray, what? From the tip to optic center. So tip, this is optic center. Right. So optic center. Okay. So this is our refracted ray. Okay, so where it is intersecting now, you observe here. It is intersecting at this point. Right. So this point you have to mark as a B dash point. So from there, you have to draw foot of perpendicular on the principal axis. On the principal axis you have to draw. Right. You have to draw foot of perpendicular on the principal axis from this point. Okay, so draw it. Right? So this is our A dash. So this is our image. Now, where the image is forming now? It is forming beyond C. So you have to write image. About what the image. So you have to write it about the image. First point, the image is formed beyond C, means beyond 2F length, which is opposite to this condition, opposite to this. So object kept beyond C, image is forming between F and C. So here object is kept between F and C. Okay, and here the image is forming what? Beyond C. Okay. Now second point about the nature. So it is same because two rays are intersecting each other. So it is a real image. Next, because the opposite direction, so inverted image. Inverted. And now you observe here you have taken 1 centimeter, here you got approximately 1.8 centimeter, means larger size. So we write here magnified. Magnified means the size of the image is enlarged. So now you observe here 4 diagrams I have drawn here. 1, 2, 3 and the fourth one. And here this is the fourth diagram. Got it? Okay. So this is 4 condition over. Now coming to the 5th condition. Now here also you have to draw same thing. Same thing you have to draw. Same. Where you have drawn here. So let us draw the lines first. Okay. So where the principal axis we have drawn from the top. Let us calculate 1, 2, 3, 1, 2, 3, fourth point. Okay, and from down 1, 2, 3, 4, 5. Okay, fourth point. Fourth and left side downwards what? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So from the top 4th line and from that 6th line. Okay, from the top 4th line. So 4th line means 1, 1, 2, 3, 4th. Continue to write elongated line so that at a time all the diagram will come. Up to the block. So don't touch the block. Right. So principal axis we have drawn already. Okay. Second one, let us check where we have drawn. So second one. Which line? 1, 2, 3, fourth line. So from down also fourth line. From down also fourth line. 1, 2, 3 and fourth line. So this line. So here also you draw the principal axis. Our 8 diagrams are going to be ready. Okay, so here now 6th line, 6th point. 1, 2, 3, 4, 5 and 6. So 6 means 3 centimeter up and 3 centimeter down to the principal axis. Means 3 division. Okay, so here 3 centimeter, 1, 2, 3 centimeter up and 3 centimeter down. Similarly here 1, 2, 3 centimeter up, here 3 centimeter down. Okay. Over. Right. Okay. So a second diagram let us check from where. 1, 2, 3, 4, 5, 6. So from the right 6. Let us check from the right. 1, 2, 3, 4, 5 and 6. So this is the line. Okay, same 3 centimeter up and 3 centimeter down. Right. Here also same 3 centimeter up and 3 centimeter down. Right. So then you have to mark it. What? Same as it is already said before. So these two will be for convex lens. And these two will be for concave lens, because concave lens only we have two diagrams, the case 1 and case 2, whereas in this case 4 already over, ABCD over. So this is E and this is F. Okay, 6 diagrams are there. And mark same L dash, optic center O, 2 centimeter, F1 and 2 centimeter, C1, left side 2 centimeter, F2 and more 2 centimeter, maybe 4 centimeter is C1. Here also same L dash, optic center O, next F1 and C1, next F2 and C2. These two diagram will go later on. Okay. Now fifth condition is what the object is kept at F. Where the object is kept, so object kept at focal point or focus, that means F length. So here you take what at 2 centimeter you draw height of 1 centimeter, you can take 2 centimeter also you can take, there is no problem at all. So take 1 centimeter or 1.5 also you can take. I have taken 1.5 here. Okay, so mark this as A and B. This is our object. As per our rule, you have to draw parallel beam of light from the tip and it should pass through the focus. It is passing through the focus, the refracted ray. Second one through the optic center. Through the optic center. Right? So, you pass through that, it is a straight line. Right? So, this is our refracted ray. So, you observe these two rays are remaining almost parallel. Almost what? Parallel. So, we write here, what we have to write about the image. About the image is, point number 1, the image is forming at infinity. Okay. So it is the opposite to the first case. This is the first case. When the object is kept at infinity, image is forming at focus. But here what if the object is kept at focus, the image is going to form at infinity. And the nature is unknown. But it is unknown. Okay. Because where it is going to form we don't know. So we write as the nature is unknown. Okay. The last one is the object kept between F and O. F and O. So object is kept between F and O. So that is your focal point, your F focus, that means F point, and optic center O. Optic center what? O. This is optic center. So now you have to, because the focus point is 2 centimeter, you keep the object at 1 centimeter, and you take only 1 centimeter height, so that because this side, in this diagram will come on the left side and little bit larger, sometime it may come. So that's why you take only 1 centimeter height. Okay. So this is only 1 centimeter height you take. And mark this as A and B. This is our object. Okay. Now as per the rule, what do you have to draw? First, parallel beam of light. And it should pass through the focus. So it is passing through the focus. Okay. So as the diagram, the ray diagram is going to form on the back side. So what I am going to do, from this I will draw dash line, because these are the not real rays. So these are the virtual rays. And this is the solid line. This is the real rays. So because I have drawn, I have used the scale at a time. So again when you will go for drawing the second time, so what will happen? Now sometime it may bend. So we can avoid that. Okay. Second, from the tip, you have to join to the optic center. It remain undeviated. So you can observe from the scale, this lighter diverting, means diverging. So you have to elongate on back side. So back side you use a dash line, because these are not the real rays. These are the virtual rays. And front side you draw the solid line. So this is the real rays. Okay. So this is our incident ray. Okay. So now you observe where the intersection occur. So on the same side of the object. So from there you have to draw a foot of perpendicular on the principal axis. Yes. But here you don't use the dash line, because this is a virtual image. So you use, don't use a solid line, because it is a virtual image. So use dash line. Okay. So this is a dash line. And mark this as A dash, and this is our B dash. This is our image. Now you have to write the position and nature of the image formed. So you have to write about the image. So where the image is formed? Here image is formed. Point number 1. On the same side of object. On the same side of the object. Second, nature. So what is the nature? You can observe here, because we have used a dash line and object image is forming on the same side. It is a virtual image, because these two rays are not meeting each other. So these are splitting. So we get an image. This image we call as virtual image. Virtual. Okay. And you observe the direction you observe here. I kept upward. Here also upward, means same direction. So we call it as a erect. We call it as what? The erect image. And here what the size you observe? We have taken 1 centimeter here. We get more than 2 centimeter. Means it is magnified. Okay. So in convex lens, we will get 5 condition as real image, 1 condition virtual image. So this is about your what? Convex lens. Now coming to the concave lens. So in case of concave lens, the arrow mark diagram you have to use in reverse. In what a convex lens you use like this. In concave lens you have to mark like this. And mark this same as L, L dash, optic center O, same. 2 centimeter F, and more 2 centimeter means 4 centimeter each. But here you are marking what? F1, C1. So this side you mark as a F2 and a C2. Right. This side you mark same as a F1 and 4 centimeter is a C1. Okay. In the same here also the same thing. Okay, so mark this L dash, optic center O, and this is our F2, this is our C2, and this is our F1, this is our C1. Okay, so it has only two diagram, so no need to worry. So first, object kept at infinity, right? So object kept at infinity. So when object kept at infinity, we get parallel beam of light. So first condition of convex lens, same you have to draw parallel beam of light. So 5, 2 up and 2 down. So this is a 2 up. So first one up, above the principal axis, and this is the second one above the principal axis, and this is the down, first one down, then the second one down. Okay, so mark this as a incident ray, arrow mark like this. And you know, in case of a convex lens, a concave lens, all the parallel beam of light, they seems to be diverged from focus. So this is the focus. So from there, you have to draw foot of perpendicular, you have to join the line. That is joining to focus. Because these rays are these rays are virtual rays. That's why you should use dash line. So this is dash line, and this is solid line. Right. Second one also same. You have to use dash line back side and solid line front side. This is the solid line. These are real rays. Okay. From up also same. Back side you have to use dash line and solid line front side. Okay. So here same dash line back side and solid line front side. So here you can observe here that these 4 rays, they are diverging from focus. So that's why here image also going to form at focus. But it is not a real image. It's a virtual image. So you have to write about image. So where the image is going to form? The image is going to form at, first point, at focus means f length, on the same side of the object. Same side of object. Okay. The second point, the nature, because we get dash line here, so this is a virtual image. Virtual, and it is erect and highly diminished. Highly diminished. That means it behaves like a point size. Okay, last diagram. Okay, so last diagram, which is the 8th diagram, or it is the second diagram for what? A concave lens. The object here kept at any point. Remember, any point means you can keep it O to F, or in between O and F, or you can keep it F, or you can keep F and between F and C, or at C, or beyond C, whatever the position may be, whatever the position may be. You can keep at any point. That's why I wrote any point. Okay. So the ray diagram is same. Ray diagram is what? Same. So let us take object kept at beyond C. Okay. I am taking little bit larger here, 2 centimeter height. Okay. So I kept beyond C. That means at 5 centimeter I kept here. So 2 centimeter height. This is my object. And mark this as A and B. This is our object. Okay. Now as per our rule, you have to draw, put a parallel beam of light. So this is your parallel beam of light. And it seems to be diverged from the focus. So diverged from the focus means your from a point you have to draw dash line backside. Okay. So dash line should be used here because it is not the real rays. This is the real rays. Okay. Second one, to the optic center. So to the optic center here what? Now every ray whatever may be, it remains undeviated when it passes through the optic center. It is a real rays. So now where the two rays are intersecting, so this is the intersection point. So from there you have to, because it is not a real image, it's a virtual image. So what a dash line you have to use. And mark this as B dash. This is our A dash. So this is our image. Got it? So whatever the position may be, so here the image will form. So you have to write as image, about the image. It will form on the same side of the object. Same side of object. It may form between F or sometime beyond F also it can form, but it will form on the same side of the object. Second one, the nature. So nature you observe here, because this point is a deviation point, or you can say point of divergence. So because these two rays are diverging from each other, never meeting, so it is a virtual image. It is a virtual. Okay. Now you check the direction. This is B, this is B dash. So it is erect. And size you observe. Here I have taken 2 centimeter. I am getting an image just 0.6. That means it is diminished. So you can say diminished image and diminished. Okay. So whatever the position may be, so every time you will get what? Image will form on the same side of the object, and it is virtual, erect and diminished. So this is the second condition. So now let us recapitulate all. Okay. First, if the object is kept at infinity, we get a parallel beam of light, and all the parallel beam of light after refraction they pass to the focus. So image will form at focus, and it is real, inverted and highly diminished, that means point size. Second condition, if the object is kept beyond C, means 2f length, means total 2 times of focal length or beyond radius of curvature, we will get the image. It will form between f and C, means small f length and 2f length, and it is real, inverted and diminished. Okay. The third condition, if the object is kept, your better kept at C, means 2 times of focal length. Here already I told you have to take the height as only 1 centimeter. Don't take more than 1 centimeter. Otherwise diagram you will not get. So here as the object is kept at center of curvature or radius of curvature or 2 times of focal length, the image is also going to form at the C or 2A planes, and it is real, inverted and same size. Okay, the fourth one is your what? Object kept between focus or focal length and center of curvature. So here these 2 points, or C and F. Okay, so F length and 2F length. So here you will see this is the image. Okay, so you will observe that the image is going to form beyond C or 2 times of focal length. And then the nature of the image is real, inverted and magnified. Okay, this is the fourth one. Okay, then the fifth one, the object kept at focus. As the object is kept at focus, the image is going to form at infinity. And because these two rays are not meeting anywhere, we don't know whether it will meet or not. So nature is unknown. Okay. Then last is what? The object kept between focus and optic center, means within focal point. Okay. So we will see there that image is forming on the same side of the object. It is virtual, erect and magnified. Okay. Coming to the concave lens. So when the object is kept at infinity, we get parallel beam of light. There seems to be diverge from the focus. So we get image at focus on the same side of the object, and it is virtual, erect and highly diminished. So point size. Now, if the object, second condition, if the object is kept, okay, at any point, So you can put at F, you can put between F and C or beyond C, any point. So there the image will be formed on the same side of the object, and it is virtual, erect and diminished. Got it? So this is your what? The total 8 diagrams. Now this 8 diagram, you have to what? You have to draw a table so that you can summarize the table. You can summarize the table. In your graph sheet backside, sometime for table already lines are there. I don't have, so I am drawing the lines. And for convex lens, I have to draw six boxes. I have to draw 6 boxes. One, two, three, 4, 5 and 6. Right? Okay. And for concave, you have to draw what? 2 box. So here I am giving the gap for concave. So here 1, 2 and the 3. Right. This is for convex lens. And this is for concave lens. This is for concave lens. Right. Okay. So because all have same common point only, so you have to first go for serial number. Serial number here. Let us write serial number 1, 2, 3, 4, 5 and 6, and this is 1 and 2. Right. Then you have to write position of the object. Position of the object. So let us take a little larger length. Okay. Alright. Then position of the image. Right. The position of the image. And last is what the nature. So first point is what the position of object. Position of object. Next is your position of image. Okay. Then last is the nature of image that is formed. Okay. First one, object kept at infinity. The image is formed at focus, and nature is what? The real, inverted and highly diminished. Highly diminished. That means point size. Okay. Second one, beyond C. Beyond C. So image will go form between what? The F and C. So it is real, inverted and diminished. Okay, next, at C. At C. Image is also going to form at C. It is real, inverted and same size. Next is a object between F and C. Where the image will form? This is opposite to second point. This is opposite to second point. So here image is F and C, object is beyond C. So here object is between F and C means image will form beyond C. Beyond C. And the nature will be real, inverted and this is opposite, this is diminished, so it will be magnified. Okay. Next, the object is at focus. So it is opposite to first point. So image will be formed at infinity. Right. It will be, nature will be unknown. Right. Last, if the object is kept between focal point and optic center O. So image is going to form on the same side of object. Same side of object. And nature is virtual, erect, and magnified. Okay. Next, for concave. First point is at infinity. If the object is kept at infinity, the image is going to form at focus on the same side of the object. Same side of object. Same side of the object. Okay. And the nature is virtual, erect, and highly diminished. Highly, okay, diminished. Means point size. Point size. Then last is what? Last is for any condition at any point. Okay, image is going to form on the same side of object, and it is virtual, erect, and diminished. So this is the table, grocery table you can form here. Okay, so now understood how to draw the ray diagram perfectly. So if you have good practice on the graph sheet, then you can draw it on a rough paper very nicely. Otherwise, sometimes it may go wrong way. So thank you. Right. Bye bye.